Section 8.1, Points, Lines, Planes, and Angles. A point, line, and plane are three basic terms in geometry that are not given a formal definition, yet we recognize them when we see them. A line is a set of points. Any two distinct points determine a unique line. Any point on a line separates the line into three parts, the point itself and two half lines. A ray is a half line, including the endpoint. A line segment is a part of a line between two points, including the endpoints. Here's a table that shows the basic terms with the descriptions, the diagrams, and then the symbols that are used to specify those particular line parts or lines themselves. Identify the figure as a line, half line, ray, line segment, open line segment, or half open line segment. And I should clarify, by an open line segment, that means that the endpoint is not included. And if you notice in some of the answers here, the little dots are not filled in, and that means they're open line segments, or the line segments being referred are open. Determine the figure by its approximate symbol. So what you're going to focus on is the blue part of the line here. So we do have a whole line here in black, but the thing we're trying to identify is the blue portion here. And we notice that it starts at H, and then there's an arrow going to the right-hand side. So this is a ray, and the ray includes the endpoint, and we always name the ray with the endpoint, and then we have a little arrow, and we see that in this choice right down here. So this is ray HK. And we say the H because that's the endpoint, and by the description and the way we name it, the reader knows that H is the endpoint included in the ray. We can think of a plane as a two-dimensional surface that extends infinitely in both directions. In fact, this screen here is a plane. Two lines in the same plane that don't intersect are called parallel lines. Any 3 points that are not on the same line, non-collinear points, determine a unique plane. So here we have plane ABC. A line in a plane divides the plane into 3 parts, the line itself and 2 half planes. Any line and a point not on the line determine a unique plane, and the intersection of 2 distinct non-parallel planes is a line. And you see this little diagram here. It looks like cubicles in an office, or maybe the dividers that go into boxes to separate items when they're shipped. 2 planes that do not intersect are said to be parallel planes, so we see 2 here. FGH is a plane that is parallel to the plane ABE. 2 lines that do not intersect in the same plane, that do not lie in the same plane and do not intersect are called skew lines. Angles. An angle is the union of 2 rays with a common endpoint, and it's denoted with this little symbol here. So here we see an angle. We see the vertex here is B, and actually we see it's the union of 2 rays. So here it would be ray BA and ray BC are joined together at the vertex B to form this angle here. And the little arrow inside will tell you which angle we're describing, and we're describing the interior angle here. The vertex is the point that's common to both rays. The sides are the rays that make up the angle, and there are several ways to name an angle. You can name it with the 3 points that define it, and the vertex is, when you're using 3 points, is always going to be the middle point. So we could call this angle ABC, or angle CBA, or simply angle B, with simply the letter that indicates the vertex. The measure of an angle is the amount of rotation from its initial to its terminal side, and can be measured in degrees, radians, or gradients. I'm going to use a device here to do the measurement. In this case, this angle here is a measure of 50 degrees. Angles are classified by their degree measurement. A right angle has a measure of 90 degrees, an acute angle has a measure less than 90 degrees, an obtuse has a measure greater than 90 but less than 180, and a straight angle has a measure of 180. And here's a picture of those angles: a right angle, acute angle, obtuse angle, straight angle. And notice the little arrow here. This is the initial side, this is the terminal side, so it indicates which angle is being measured. Adjacent angles are angles that have a common vertex inside but no interior points. Complementary angles are 2 angles whose sum of their measures adds to 90 degrees. Supplementary angles, sum of their measures is 180 degrees. Determining complementary and supplementary angles. So in the figure here, we see that the measure of angle ABC is 31 degrees. ABC and CBD are complementary, so we want to determine the measure of angle CBD, and likewise angle ABC and angle CBE are supplementary, and we want to determine the measure of that angle. So we know again that angle ABC and angle CBA are complementary, and those angles sum to 90, so we can write an equation. The measure of this angle plus this angle is 90, and we know the measure of the first angle is 31 degrees. Subtract 31 from both sides, and we get the measure of angle CBD is 59 degrees. Then we're going to do the supplementary angle, the CBD angle, and we know that this angle measure plus the 31 has to equal 180. Subtract 31, and we get the measure of angle CBE is 149 degrees. In this figure, angles 1 and 2 are complementary. Find the measure of each angle. So we can write an equation here. We know the measures of complementary angles add to 90, so we can write an equation. The measure of this angle, which is 5x minus 6, plus the measure of this angle, which is x, has to equal 90. Simplify on the left side, so 6x minus 6 equals 90. Add 6, divide by 6, and we get x equals 16. So we know the measure of angle 1 is 16 degrees. We need to figure out the measure of angle 2. So we can use the information we were given here to figure out the measure of angle 2. 5 times x minus 6 gives us 74. We can also use the fact that they're complementary and say 90 minus 16 must give me the measure of angle 2, which is 74. When two angles intersect, the non-adjacent angles formed are called vertical angles. Vertical angles have the same measure. So if you look in this picture here, angles 1 and 3 are vertical, angles 2 and 4 are vertical. And also notice angles 2 and 3 are supplementary, angles 1 and 4 are supplementary. A line that intersects two different lines at two different points is called a transversal. And line 1 and line 2 are generally going to be parallel lines. Special names are given to the angles that are formed by a transversal. So if we look here at the figure, for on the interior and on the opposite side, interior angles on the opposite side are called alternate interior angles. Alternate exterior angles are on the opposite side of the transversal on the exterior of the two parallel lines, and then corresponding are on the same side of the transversal, one interior and one exterior. What's interesting about this is alternative interior angles have the same measure, alternative exterior angles have the same measure, and corresponding angles have the same measure. And that helps us when we're trying to work on a transversal problem. So let's work an example here. We were given here a transversal, and we were given the measure of angle 8, and we want to find the measure of the remaining angles. So what do we know? We know that angle 8 and angle 7 must be supplementary, so we can go ahead and find the measure of angle 7 by subtracting 52 from 180. Now, what else do we know? We know that angle 8 and 6 are vertical, so they have the same measure. Likewise, angles 5 and 7 are vertical, so they have the same measure. So we can fill those in. We also know the interior alternate angles have the same measure, so we could fill those in. And again, vertical angles have the same measure, and then we can go back on the others and fill those in. So these are vertical here, so they have the same measure. And come back down here, and we can fill in all the remaining angles. And again, there's a little summary of the angle measurements and why they had the same measure, whether they were vertical, supplementary, alternate interior, or alternate exterior angles. Which angles are vertical? So which are vertical here? And that's choice B. Notice those are vertical angles. Which angles are supplementary? Supplementary means they have to add to 180 degrees, and that would be choice D. Which angles are corresponding angles? Corresponding angles on the same side of the transversal, one interior and one exterior, so that's choice C.